1.4a, Introduction to Variables and Substitution. A variable is a placeholder for a number in an expression. An expression containing variables is called an algebraic expression. So when people are doing algebra, what they are doing is handling expressions containing variables in them. We can substitute variables with numbers. So let me show you what I mean by a variable and how to substitute for it with these examples. So example 1, evaluate x plus 3 at x equals 4. So this expression contains a variable. X is our variable, and this is called an algebraic expression. Now x could potentially be any number, but we've been asked to evaluate it at x equals 4. So all we have to do is replace every instance of x in the expression with 4. So x plus 3, if x equals 4, this becomes 4 plus 3, which is just 7. So the expression x plus 3 at x equals 4 is 7. Pretty straightforward. But now let's try it, including PEMDAS. Compute 2x minus 3 squared at x equals 1. So to compute this, we need to substitute in for x at the beginning. So we replace every instance of x with 1 in the expression. So 2x minus 3 squared ends up equaling 2 times 1 minus 3 squared. So using PEMDAS, we have to take care of everything in the parentheses first. And in the parentheses, what takes priority is the multiplication rather than the subtraction. So 2 times 1 equals 2. We leave the minus 3 and we leave the squared. So now we handle the subtraction. This ends up equaling negative 1. On the inside of the expression, we leave the squared. We handle the 2 minus 3. And now negative 1 squared is just 1. So look at that. Our expression ended up equaling what our variable equaled. This doesn't always happen, but it happened in this case. So our expression at x equals 1 is also 1. So let's now look at an example of using algebraic expressions to model a real-life problem. So we know our car's windshield is twice as wide as the windows on the door. If the door windows are 2 feet wide, how wide is the windshield? Set up an algebraic expression to get the width of the windshield. So our car's windshield is twice as wide as the windows on the door. So W, we'll call that our windshield, equals 2 times the width of the door windows, 2D. So this expression has 2 variables. We want to find W, that's what we're asked to find, and they give us D, D equals 2. So we have to evaluate 2D at D equals 2. So all we have to do is plug in a 2 for D, so W equals 2 times 2, which is just 4. So our car's windshield is 4 feet wide.